Greetings, detectives. Mrs. McKay here, and we are in the middle of case 2. We're on our third learning target clue, and we're going to go ahead and write that in right now. I can determine solutions to linear equations using tables, graphs, and equations. So make sure you've got all of that written in. Before we do any more, let's just do a quick review. We've got some vocabulary over to the side. Quantities and units. Quantities is the general thing that we're measuring. Units is how we're going to measure it. So we might measure time, that's our quantity, but our unit is going to be days, minutes, hours. We might measure weight, but our unit is that would be our quantity. Our unit would be pounds or milligrams or kilograms. So quantity is the big general measurement. Unit is the specific measurement. Hope that makes sense. Linear function, that's the one thing that we're probably the most familiar with. It is usually graphed as a line. Well, not usually, it's graphed as a line, and it has an x and a y variable. You can graph it on the coordinate plane, and you understand what a linear function is. A table looks like this, usually an x and a y, an independent and a dependent variable, and then you fill in when x is 0, y is 1, when x is 1, y is 2, whatever it is that we're filling in. It's whatever our function is determines what our y is. A graph is graphed on a coordinate plane, usually the graph of a linear function. Well, usually if you're going to graph a linear function, it's a line. And then the equation of a linear function looks like this: y equals mx plus b. It actually has other forms, but that's the one that we use the most. We also have learned to recognize this: f of x equals mx plus b, where f of x is the y value. It's the dependent value, and x is the independent value. M represents the slope, and b represents where it crosses the y-axis. All right, let's get started. We've spent some time looking at these different things, being able to represent functions using tables, graphs, and equations. Now we're going to use tables, graphs, and equations to actually find solutions. So let's get started. Let's look at this problem that I have written here. Lynn and her friend are collecting food for their local food bank. Their goal is to collect a total of 1,785 pounds of food. They start with 225 pounds donated by a local grocery store. Their goal is to collect 20 pounds of food per day. All right, so the first thing we're going to do is we're going to think about what the independent and dependent quantities are. So first of all, what's the independent quantity? What's the general measurement that we're going to be using? It's going to be time. And we're going to measure that time in what? Days. Okay? And our dependent quantity is going to be what? The weight of food, or the amount of food, right? And how are we going to measure that amount of food? In pounds. So now let's think a little bit about what's happening. On day 0, how many pounds of food do I have? When I'm just starting to try to collect, I know that I want to collect 20 pounds of food every day. But when I'm just starting, how much do I already have? On day 0, how much do I already have? It's right here, isn't it? 225 pounds. So I'm going to write on day 0, I have 225 pounds. And then On the next day, on day 1, I would have 225 pounds plus 20 pounds of food, wouldn't I? 20 pounds of food, right? So 225 plus the 20 would be 245 pounds. But my table doesn't have a 1. It has a 10. So after 10 days, how much food will I have collected? Well, I'll have 10 times the 20 pounds, because 10 is my independent variable, and I'm going to collect 20 pounds every day. So 10 times 20 would be 200, and I add that to my 225 that I started, and I should have 425. See that? Now the next thing that I want to do is I want to figure out how many pounds of food will I have after 15 days. So I'm going to do the exact same thing. I'm going to take my 15 pounds and my 15 days, and I'm going to multiply it by my 20 pounds. So 20 times 15 is 300 pounds, plus my 225 gives me 525. See if you can figure out 25. Well, what did you come up with? Did you take 25 and multiply it by 20? Or what I did was I said, well, I know what 20 is. 20 times 20 is 400. So I wrote to myself down here 400. And then I said, and then 5 times 20 is 100. And that gave me 500. So 500 for the 25. Or you could have multiplied 25 times 20, whatever works best for you. I like to break things up a little bit. So 500 plus my 225 makes it 725. Now, the next thing that we see on our table is it says after 48 days, there were 1,185. But how many were there after 1,225? Well, how would we figure out how many days it took to get 1,125 or 1,225? What I would do is I would start by saying, well, I know that I already had 225, so I would subtract that. And that gives me 1,000. Then I know it's 1,000 pounds that I've collected over the number of days. And I know that every day I collected 20 pounds. So if I divide 1,000 by 20, I should get the amount that how many days that took. So 20 goes into 1,000, the same as 2 would go into 100. So I just get rid of those. 2 goes into 100, and 2 times 50 makes 100. So I'm thinking it must be 50 days. See if you can figure out how many days it took for 1,500. 1,505. Well, what did you come up with? Did you come up with 64? If you did, then you got the right answer. 1,505 minus 225 gives me 1,280. When I divide that by 20, because 1,280 is really the amount that I collected because I started with the 225. So when I divide by 20, I get 2 goes into 12 6 times, 2 goes into 8 4 times, and those zeros cancel themselves out. So 64 days. So now we've figured out a lot of information here, and the next thing that we need to do is we need to figure out what's the general idea. What do we do when we don't know what the time is? We just say it's any time, time t. When it's X number of days, t number of days, how do we figure out how many pounds were collected? Any ideas on that? Share them. Well, we know that we have 20 pounds per day, and we add to that 225 pounds that we already had. So 20t plus 225 is our expression for our dependent quantity. It's how we figure out what the y is. So now we've just used a table and we filled in the table. All right? So now let's move on and go ahead and look at the right-hand side and write this equation that we've just written, 20t plus 225, as a linear equation. So this over here is our expression, but we're going to write it in our linear equation. So we're going to say f of t equals 20t plus 225. So when we look at this, remember f of t is the same as y, and remember that our equation is y equals mx plus b. So tell me, what is the slope? What is the slope of this line? What is the slope of this line? It's 20, right? Or 20 over 1. And what is our y-intercept? That's right, our y-intercept is 225. All right, so now we're ready to do some graphing. Let's go ahead and graph this equation using what we know here on our equation. We can either use our points from our different independent and dependent quantities from our table, or we can just graph it using what we know about slope-intercept form. So I'm going to go ahead and use what I know about slope-intercept form, and I'm going to say, let's see, if this is 200, that would be 300. So 225 is going to be down here somewhere. And then I'm going to go up 20 over 1. So maybe what I'll do is, instead of that, I'll just look at my table, because my days and my pounds are very close together. So after 10 days, I have 425. So here's 10 right here, and I go up to 425 right there. All right? I'm going to skip 15. I'm going to say after, actually, I'll just figure out after 40 days, how many would I have? Well, 40 times t, so or 20 times 40 is 800 plus 225, right? So that would be 1,225. So here's 40, and there's 1,225. And now I have pretty much something that I can connect. I know that's very sloppy, but you get the idea. All right? So there we go. So there's our graph. Let's keep going. Actually, we've done everything that we need to do. So now we're going to do a little thinking and comparing. And we're going to look over here at in this red box. It says, use the table to estimate the number of days it will take to collect 600 pounds of food. So just using the table. So let's look at our table. Well, let's see. 15 days is 525, and 25 days is 725. So what do you think? 600 pounds is going to be somewhere in between 15 and 25 days. So what would be a good estimate? That's right. I would say about 20 days. All right? Use the graph. Now let's do the next one. Use the graph to estimate the number of days it will take to collect 600 pounds of food. So let's see. We want to find where 600 is, and 600 is right about here. Here's 600, and we come over, and it looks like it's sitting at about 20 days. Excellent. And then it says use the equation to determine the number of days it will take to collect 600 pounds of food. Well, now we don't have to estimate. We can know exactly. Remember, our equation up here says 20t plus 225. So if we want 20t plus 225 to equal 600, then all I have to do is write right here, 600 equals 20t plus 225. And then I just have to solve for t. Subtract 225 from both sides. Well, I went ahead and paused it, and I have t equals 18.75. So not quite 20 days. Which one of our options, table, graph, or equation, is the most accurate? Yes, the equation is the most accurate, but that doesn't mean that we can't use the others for estimation. Go ahead and write yourself a key idea, and I'll see you in class.